Alright, so what I've done is I've plotted a point here, A, at 1, 3. And then I created the inverse of that point. If it's 1, 3, then the inverse of that, if I switch it, it'd be 3, 1. That's going to be the red point right down here. So this red point is the inverse of the blue point. So they're inverses of each other. Well, if all I'm going to do is just switch these 2 points out, if you watch this over here, these two points will always be the same, just switched. That's what an inverse does. And I'm going to let me turn this off real quick here. What I've also done is trace these points. You'll see that it traces. And if you notice over there to the side, it's the same point, just backwards. It's inverted. You see how they kind of mirror each other? It's pretty neat, right? Well, there's symmetry there, right? There's a line of symmetry. And what you've done is you are changing out the x for the y, or the y for the x. Or really, your y value equals the x value, and the x equals the y. So what happens is you have done a reflection over the line y equals x. And right there's that line. There is a line of symmetry. Runs right through there. It's just it reflects right over that line. And to show you what that does here, I'll try writing my name real quick here. So you see, it's just like looking in a mirror, I suppose. So you get a reflection there. That's pretty cool. Let's look at what would happen if it was like a mathematical graph, like a parabola. Parabolas are always fun to graph, right? Look at what the inverse of a parabola looks like. And it's not a very well-drawn parabola, but you get the idea. When you inverse something, it kind of just flips it over on its side. So you can look at the inverses of graphs. And in this case, we have an inverse of a parabola.